Okay, now we can go for our second experiment. Okay, see here, our second experiment is to write a program in MATLAB to perform autocorrelation of discrete sequence and cross correlation between two sequences to verify autocorrelation properties. So that is your second experiment. So here we are performing two functions. One is autocorrelation and one is cross correlation. Cross correlation means two different signals. Autocorrelation means both same signals. So that is the difference between autocorrelation and cross correlation. So here you can observe the two programs. First one, you can go for cross correlation. Cross correlation nothing but you can perform two different sequences. That is, one is x of n, another is h of n. So one input sequence is x of n, another input sequence is h of n. So here by using MATLAB function x corr x comma h. By using this function, you can perform the cross correlation between two sequences x of n and h of n. While going for program, first enter the input sequence x, the second one impulse, enter the second input, y equal to x correlation of x comma h, z equal to x correlation of h of x. We are performing two functions here. We are finding cross correlation between x of h, the result is stored in y. Cross correlation between h and x, the result is stored in z. And length is L1 is length of x, L2 is length of h. The maximum of L1 and L2. So which is maximum, that can be considered as a L. And similarly, L1 limits, 0 is the limit, L1 minus 1. L1 minus 1, increment is 1. Now N2 is 0, final value is L2 minus 1, increment is 1. N3 minus L plus 1 initial value, final value L minus 1 is increment 1. So subplot of first one, N1, next subplot of N2, subplot of N3, subplot of here x, h, y, z. So x is the input, h is also input, y is the cross correlation between x and h, z is the cross correlation between h and x. So that is here enter the input sequence 1, 2, 3, 4, enter second sequence 1, 1, 2, 1. Between x and h you can get result y. Between h and x you can get result that is z. The same thing you can display in graph. First one is x of n, starting from 0, increment is 1, final value is 0. So 0, 1, 2, 3. The impulses are here sequence 1, 2, 3, 4. So you can apply 1, 2, 3, 4. Second one 0, 1, 2, 3 for h of n. We have to take as samples are 1, 1, 2, 1. 1, 1, 2, 1. Next convolution and cross correlation between these two functions x of n and h of n can get y of n. So what is y of n? 1, 4, 8, 13, 13, 7, 4. So that is displayed here. Next similarly h of z equal to cross correlation of h comma x. So that is 4, 7, 13, 13, 8, 4, 1. So that is you can display it here z. So in this way we are finding the cross correlation between two sequences. X of h is stored in y, h of x is stored in z. Next one we can go for autocorrelation. So autocorrelation already we are saying that x of n with delayed version of same sequence. So same sequence we have to take, that is considered as autocorrelation. Two different sequences you can consider as cross correlation. So just observe here. Here in this case, the MATLAB function used for autocorrelation is x corr of x. Just x is the input sequence, enter the sequence, y equal to x corr x comma x. L is length of x, n1 is initial value is 0, final value is L minus 1, increment is 1, n2 initial value minus L plus 1, final L minus 1, increment 1. So here simple subplot of 2 rows, first column, first figure, 2 rows, first column, second figure. So first one is x of n, second one is y of n is nothing but x of n with x of n minus k. So that is you can get here y is 4, 11, 20, 30, 20, 11, 4. So you can get sequence first x of n, y of n is autocorrelation of these two sequences. So that is the autocorrelation between single sequence delayed version of another sequence. So these are the two experiments, cross correlation and autocorrelation performed by MATLAB, you can get cross correlation means between two different sequences, auto correlation means same sequence. Okay, thank you, students.